All right, so let's take a look at problem number 2 from the 2021. I'm subbing for somebody right now, so I have students in my room, so I'll do a video with a mask on, but that's all good. This is actually one of the more straightforward questions. It kind of just works quickly. So let's review what it says here. We have these two particles, particle P and particle Q here of given velocities. And they also, in each case, gave us an initial condition or a starting point. So keep in mind, when we integrate the velocity, we don't actually get the position, we get the displacement. So I made a little notation to myself off to the side that we have that. And so what this is remembering is that you want to remember that fundamental theorem of calculus, that when we do that, we have some kind of the position at some time t is equal to the position at some given value, which is, I'm going to call x sub I, like some value we know, and then the integral from that x sub I up to that time that we're interested in, of v of t dt. So we're needing to look at that very, very carefully. So this one is one of the more straightforward problems. So I'm just going to undo my answer as I go. So I notice in A, if I wanted to know where that particle is, particle P at 1 would be 5 because that was its initial condition that I was given. Plus, again, 5 happened at time 0, so from 0 to 1. So here's time 0 and then 0 to 1. And again, this is the calculator active, so I didn't even sweat this at all. I literally just typed this one as Y1, and I just went and got it. So 5 plus that FNINT gave me 5.371. Now, this is not its displacement. That's actually where it was. So that actually tells me it started at 5 and it went forward at 0.371 in that second. Now, Q, of course, started at 10. So again, there's my initial condition. So at 1, it moved from 0 to 1, but it started at the value 10, and I got this. So that actually tells me if it started at 10, it was actually going backwards a little bit. And that is somewhat helpful for part B. Now, in part B, what I did is I did two things. Now, keep in mind, this is calculator active. And so all I did is I used the positions that I got from this portion right here. Notice that I've got the two position functions. So I know point P is to the left of point Q based on the position from A. And then I did a numerical derivative of Y1 and a numerical derivative of Y2 right here. And I found those two values. Now, what that actually tells me is that P has a positive velocity and Q has a negative velocity. And so since P is to the left with a positive velocity and Q is to the right with a negative velocity, that chicken scratch there that I kind of just made very quickly indicates all that. But since Q is to the right and moving left and P is to the left and moving to the right, that those things are moving towards each other. Now for C, the acceleration, we would want to do the derivative of that. So again, this is calculator active, so I just use a numerical derivative of the Q function, A sub V sub Q. And since the acceleration and the velocity are opposite signs, because up here we figured out that the velocity was negative and the acceleration was positive, so that tells me that in fact the speed is actually decreasing, or in fact it is slowing down. And then last but not least, the total distance traveled by particle P. Again, keep in mind that we're talking about the calculator active section. So I just went from 0 to pi. That's the interval they asked about. And I went ahead and I let my machine do all that heavy lifting. And I just threw an absolute value around that when I did my numerical integral. So I just did an FNINT of this function. I surrounded it with an absolute value. Now, if you do this, your calculator will sweat hard. It had a hard time calculating this because it's a fairly difficult integral, with a lot of information on it. But again, it can handle it. And that's the value that popped out. And that would be the total distance traveled by that particle moving left and right and all that kind of stuff over that 0 to pi interval. And that is question number 2. But I don't think that's one that most of you are going to struggle with quite as much. So I'll come back with number 3.